Hi there, welcome to DesignSpark Ask the Expert, where today I'm going to be talking to TE Connectivity, and we're going to be looking at the landscape of industrial automation and how that's changing. So pretty much with the advent of AMRs and AGVs within warehouse automation, there's quite a lot to unpack today. And I have Guru from TE Connectivity. Hi Guru, would you like to introduce yourself to DesignSpark?
Hi there. My name is Guru Prasad. I'm responsible for the function of business development within the industrial automation and electrification business unit of TE Connectivity. In this role, I look at an application-focused growth area of industrial robotics and warehouse automation. And I'm excited to say hello to DesignSpark and be a part of this conversation. Thanks for inviting me, Greg.
Great. Well, yeah, fantastic for joining us, Guru. I'm really looking forward to the conversation. Now, if I go back into warehouse automation, there's quite a lot of change, since when I started work originally back in the 80s to where we are now in the 2020s. I have seen the warehouse facilities change quite drastically in that time. And obviously today we're going to talk about AMRs and AGVs. Can you just explain what are the mega trends driving warehouse automation, and where do those products actually fit within the scheme of things?
Sure. That's a very good question to start with. If you look at the mega trends or market drivers in general, it differs by the different customer groups which we have in warehouse automation. If you look at e-commerce, for example, e-commerce or in general any form of online retailing is fundamentally a logistics business driven by margin improvement from
Yeah,
cost reduction, inventory management, order fulfillment, and delivery capabilities. Every aspect of this value driver requires automation, whether it is in the form of automatic identification of SKUs placed in the racks or warehouse management software, which provides an accurate movement of the inventory in and out of the warehouse, or warehouse automation equipment like conveyors, shuttles, industrial robots, cobots, mobile robots, which gets the goods to person after undergoing various cycles of identification, sorting, buffering, sequencing, etc. Then similarly, if we look at e-commerce and third-party logistics put together, optimization of space is another mega trend where our customers need dense vertical storage of pallets with goods and automation like stacker cranes to securely deliver them to the order processing bay. And third mega trend which we look at is the last mile delivery, where automation once again is helping to sort daily orders in mini fulfillment centers built around densely populated urban areas. The final mega trend which I would like to present here and discuss about is getting orders to the customers within a few hours. So there is a big mega trend where AGVs and AMRs are also being used for outbound delivery or outdoor delivery, and that is once again gaining traction. So in this scheme of things, mobile robots form an important part of the warehouse automation landscape. Great.
yeah. So as I was mentioning, back in the 80s, a lot of what we were seeing about the storage and retrieval was manual. And now with the AMRs and the AGVs, their roles in the warehouse for automation, how are they different from other methods? What makes them really a kind of good fit for that kind of environment?
Yeah. First, let us look at what are AGVs and AMRs. So AGVs are wheel-based and computer-controlled load carriers running on batteries and moving around the warehouse or shop floor without requiring a driver. They navigate through different techniques, for example, following magnetic tapes pasted on the floors, optical sensors, a technology called light detection and ranging, which is abbreviated as LIDAR. And then there is another technology called as simultaneous localization and mapping, or abbreviated as SLAM. Now, what it is once again called as VSLAM because a lot of camera is being used for the SLAM navigation.
Yeah.
In the past, AGV routes used to be pre-programmed, but now with the advances in LIDAR and VSLAM combined with artificial intelligence, allow the AGVs to move more autonomously or follow what we call it as a natural navigation. So AGVs also are supposed to work alongside humans quite naturally. thanks to the functional safety devices which form an integral part of them, basically to avoid collision and also to enable obstacle detection. And AGVs are working with the instruction which they get from the fleet management software via wireless communication to start and stop, to change speed, lift or lower the goods carried on them, change their path, and interact with other material handling equipment around them. So fleet management software connects the AGVs with WMS. And now if you look at the more trendy term of AMRs, the term AMR, which refers to as an autonomous mobile robot, is basically a marketing terminology, and it is not defined in ISO 8373, which governs the vocabulary used to speak about different types of industrial, service, and mobile robots. Cobot mounted on an AGV has also been loosely called an AMR. As the mobile robot market is evolving towards more autonomy, for
Mm-hmm.
the sake of this discussion, we can use the term AMR as compared to an AGV. So I would prefer to use the term AMR going forward.
Fantastic. Yeah, great. That really kind of paints a really good picture of the practicality of these vehicles within that operation. And interestingly enough, you mentioned safety there, working with people. One of our previous ASSI experts, we were talking about the sensor capabilities within industrial robots when they were around people. So that really does make a good kind of correlation between the autonomy with which they work with, but how they actually interact within the warehouse situation. So in terms of T connectivity, if we're looking at these products, where is a good fit for T connectivity with these mobile robots?
Yeah, I think it's a wonderful question. Within T connectivity, we look at warehouse automation as a combination of multiple subsystems where we can offer our products and solutions. Some of these subsystems, which I'll explain now, are ASRS or shuttle, electrical forklifts, industrial robots and cobots, and mobile robots. In case of mobile robots, TE has been a pioneer in developing multiple charging solutions, following the technical evolution of these AMRs. Also, TE has been continuously evolving the DC contactors portfolio across different businesses within TE, which finds major usability in AMRs, as and when the charging currents go higher in manual or autonomous forklifts as well as AMRs.
Fantastic. The issue of battery technology. So, for example, we were talking about e-forklifts. What is the role of lithium-ion within warehouse automation, particularly when it comes to forklifts, and why is that such an integral part of the warehouse? What's happening in terms of that battery technology?
Yeah, forklifts definitely form a very integral part of the warehouse, as you rightly said, because the automation levels inside the warehouse are still comparatively low as per the expectations what we had maybe 5 years before when Amazon started automating their warehouses in a very big way. As we speak, till now also the number of automated warehouses within US is less than 25%. So considering this scenario, electrification of forklifts from their erstwhile IC engine powered ones have been going on for more than a decade. Electrification started off with lead acid batteries,
Mm-hmm.
owing to the availability of technology, supply chain cost, and then other typical economical factors. But of late, the advancements in lithium-ion batteries have ensured forklifts to shift from highly inefficient lead acid to lithium-ion. But the interesting inflection point has been reached only now, where 2025 is expected to be the first year in which more than 50% of the forklifts in important markets like China and some parts of Europe will be with lithium-ion batteries.
Mm-hmm.
And forklifts with lithium-ion batteries, why they are becoming more and more predominant is because they offer opportunistic charging, which means at every opportunity available, for example, during a lunch break, the forklift can be put up for charging with charging currents as high as 400 amperes. the charging time required is becoming lesser, making opportunistic charging all the more attractive. Great.
Yeah. I think that's a really good point to talk about the opportunistic charging, because in terms of warehouse efficiency, that is going to make sure that everything is at its kind of maximum potential, if you like, because there'd be nothing worse than waiting for a couple of units to charge, and you need to get products ready for dispatch, distribution, etc. Now, in terms of the T connectivity with e-forklifts and AGVs, what are the product ranges that T can actually utilize to give advantage to those products, those robots?
Yeah, when it comes to the AGVs and AMRs, we can speak about two areas where T products are already available in the market and continuously evolving. One area is the charging side, and the other area is the power management side. When it comes to the charging side, one of our products which has been existing in the market for quite some time is the heavy duty charging connectors with a 0.5 millimeter of float, which offers charging currents up to 80 amperes and
Mm-hmm.
10 amperes of signal connection to support automatic docking or undocking. It offers 30,000 mating cycles, meeting all the necessary standards of CEUL 1977 and ROHS. Due to its compact size, it supports our customers' interest of reducing their vehicle size to fulfill the ever-evolving demand of low floor space, which we spoke about during the megatrends. And another product which has been in existence and is continuously evolving is called as a blind mating charging connector. The blind mating charging connector, which at present is in its 40 ampere avatar, has been in the market for quite some time and allows for a mating tolerance of plus or minus 15 mm in X direction, plus or minus 10 mm in Y direction, and approximately plus or minus 5 degrees in Z direction, which is more than enough for an AMR to pull right in and dock to the charging connector. This blind mating charging connector family with 12,000 mating cycles at present, with 2 and 3 power contact options and 8 signal contact options, truly solves the mating requirements of AMRs, blind mating requirements of AMRs up to 250 kg payload. Then when it comes to the power management side, DC contactor portfolio of TE has been continuously evolving, which finds use in the lithium-ion battery packs and also the power distribution unit of electrical forklifts and automated electrical forklifts inside a warehouse. Great.
So there's quite a lot of information there. Obviously, there's things that you were talking around with the charging currents, the mating cycles, etc. But in terms of the actual charging and power management with respect to electric forklifts, you did briefly mention a few standards there. But what are those actually evolving to in terms of power management for charging?
Yeah, interesting question because any standard gets developed when the market becomes bigger and there are more players who are looking for a standard solution. So from this perspective, when we look at the electric forklifts onto the charging side, what happens with lithium ion was electrical vehicles was the one which kind of skyrocketed the utilization of lithium ion technology.
Mm-hmm.
So electric vehicles, if we see, they are outdoors and they require maximum amount of safety and lots of different value proposition as compared to uh, any other technology. But when it comes to electrical forklifts, which are typically indoors, requirement of safety remains the same, but the value proposition completely differs as compared to the current lead acid technology. When it comes to forklifts, in terms of charging, DKE is an evolving standard within Germany, which is defining the number of power contacts, signal contacts, rated current, boost current, number of mating cycles, mating force, and all other safety aspects. In addition to DKE, there are market-driven value requirements to ensure robustness, impact absorption, easy handling, etc. So DKE coupled with customer-specific requirements are shaping the development of charging connectors for lithium-ion electrical forklifts. This is as far as charging is concerned. When it comes to functional safety, EN 1175 is a very important standard which has completely evolved, I would say, in Europe. So, DC contactors, which are necessarily functional safety products, are governed by EN 1175 2020, which defines the safety functions of the control system and also the design specifications and performance level of the safety related products like DC contactors. Even though this is basically a European standard which is harmonized for EU and designated for UK, this is a widely respected standard in all other developing economies and all other developed economies like US too. Great.
Fine, great. The the standards there also, we're talking about safety standards for charging, the correct procedures, making sure that you have the right components connected for it, for example. All this takes a lot of consideration for design, but also for anything which we're talking about automated or autonomous. There's also a couple of other areas that we need to consider. So, for example, um, if we're looking at challenges, is latency, data transfer, communications? What are the other things that need to be considered for that type of operation?
So again, a very good question, I would say. So we'll look at the challenges in the two major product areas or two major subsystems within warehouse where we look at. First, we'll speak about the AMRs. The evolution of LiDAR and VSLAM makes the AMRs truly autonomous. LiDAR and VSLAM combined with artificial intelligence enable natural navigation as we discussed earlier, which makes them the most sought after navigation technology within the warehouse automation space. But the navigation technology used has its challenges in ensuring docking accuracy when it comes to the charging connectors, especially. Keeping the docking accuracy in focus as compared to the different navigation technology in all the three direction is the most important functional design criteria for charging connectors.
Mhm.
And other non-functional design criteria we discussed earlier when it comes to following standards, when it comes to mating cycles, etc. But this is the most important functional criteria because this offers the float. Other aspects of latency, data transfer, and communication are simpler as most of the data from AMRs in the form of digital inputs and outputs are flowing into a PLC-based controller or directly into a PLC, which then communicates with a higher level of control system like a WCS. So the PLC takes cognizance of the latency, data transfer, and communication related issues. This is as far as AMRs is concerned. When it comes to electrical forklifts, the charging connector infrastructure we discussed a short while back, decay is evolving as a standard. But when it comes to what is other than the mating surface, decay defines what comes in the mating surface in terms of power contacts and in terms of signal
Mhm.
contacts, etc. The design challenges beyond the mating surface are typically what customer require in terms of robustness, controlling the heat buildup, easier handling or repair, and installation in low space areas. So these are broadly the challenges which are coming up when we speak about AMRs, AGVs, and forklifts. Right.
Fantastic. That leads me into a question which I was going to ask next. Actually, it was when designing connectors for warehouse automation. You touched upon it there, but key considerations, when we're designing for battery charging solutions for AGVs, AMRs. What is it that needs to be taken into consideration, and what is it that T connectivity are adding into those products which are going to be used in those applications?
Yeah, I have a very short answer for this, but this encompasses almost all the requirements of design considerations for charging connectors. So there are functional design aspects, uh, including the mating accuracy, number of mating cycles, operating temperature, ease of installation or rework, number of power contacts, and number of signal contacts, etc. And of course, the design considerations also need to be encompassing the conformance to standards, the most important ones being UL 1977 and other relevant European or international standards. So this is all we do when it comes to design consideration of connectors. for AGVs and AMRs.
Fantastic. And just if we finish this section on the industrial demands when it comes to battery charging solutions for, let's say, e-forklifts, what are those demands that need to be met? So I think we talked, briefly about it earlier in terms of the mating cycles and the current, etc. But just maybe as a recap to finish this section.
Yeah, as you mentioned correctly, we discussed it briefly during your question on the design criteria. Let us go a little deeper into the customer requirements when it comes to charging connectors for electrical forklifts. The first and the biggest one is the robustness. Because the charging connectors undergo significant abuse by, let us say, being thrown onto the ground or maybe even run over. And then there are other challenges of cables binding together or the handle not coming out of the cable. So these are the things first in terms of robustness, which customers look out for or the industrial demands come up with. And then there is a heat buildup. Charging always involves the heat buildup. The charger needs to be protected from the heat buildup, basically to improve its life as well as to reduce the charging time. And third, industrial demand comes from the ease of handle perspective. The charging unit assembly is expected to be heavy and difficult to carry with one hand. So the handle of the charger, the handling unit of the charger, should not only carry the weight of the charger and cables, but easy to maneuver also with single hand. And last, we spoke about the data latency, but here I would specify that industrial demand of data connection. With data connection, especially even in case of manual charging forklifts, the users would like to understand factors which would likely affect the life of the charging connector and also other aspects which would affect the failure before it happens. It's more kind of a industry 4.0 kind of a charger is what customers are looking for.
Yeah, that's a nice lead in because I was going to ask about the charging solutions from T Connectivity, but specifically around charging and battery management, for example, they're big considerations, obviously, that need to be factored in. So what advice can you share in terms of just the technology and guidance on your product ranges when it comes to those areas?
Yeah, as the product range is quite vast, I'll explain the big considerations with respect to one specific product, which is most sought after in case of warehouse automation, which is the blind mating charging connector. So, as the AMRs tend to have mating inaccuracies depending on the navigation technology, first big consideration is that the charging connector should account for these inaccuracies in terms of a float, in the form of a float in all the three directions. And with AMRs expected to be in 24/7 operations, opportunistic charging is the key. So opportunistic charging always calls for very high amount of mating cycles. This is another big consideration. With the AMRs being controlled by a PLC, the charging connectors provide an important opportunity to capture data on number of mating cycles, heat overload, etc. So this is the third big consideration which we see. Lots of AMR companies work on the robot as a service model where they rent out the mobile robots to warehouses, which typically require these in peak demand cycles, and after that they return it back. So for our customers who follow the RAS model or robot as a service model, for them the ease of installation and rework becomes an important topic or a big consideration. And last but not the least, rigidity and robustness becomes an important aspect as and when the AMRs tend to go outdoor, where we saw that last mile delivery is becoming a mega trend over there.
That's really interesting, Guru. So I'm just a couple of more questions before we finish. I'm just interested in how T Connectivity are approaching interoperability when it comes to charging, for example.
Yeah, as AGVs and AMRs typically refer to the same mobile robots, within AGV and AMR interoperability does not arise. But as we see more and more AMRs with cobots mounted on them, especially for goods to person kind of a solution, there might come a stage where we could look at interoperability. But at present, the charging solution which we have for AMRs and the charging solutions which we have for forklifts are completely different because one is automated, the other is manual. So there is, as such, no interoperability at present.
Fantastic. Now, just before we finish on this section, we were talking about opportunistic charging. In terms of wireless charging, is there an increase in demand for this, and will it be beneficial, do you think, within the automation warehouse in general?
Yeah, wireless charging is a preferred technology for lower charging currents due to low maintenance, simple vehicle control to position, and the system being fully sealed. But it is a form of inductive charging. So there is a higher temperature rise and lower efficiency. The maximum what we can see in wireless charging is 94%. So the wireless charging systems are becoming popular in case of smaller AMRs, but when the payload capacity of the AMRs goes on increasing, which increases the charging current, the customers are typically shifting towards conductive charging, which
Yeah.
is basically with the help of charging connectors. As we speak, if we look at the market leaders as on date are using conductive charging as compared to wireless charging.
Yeah, that makes sense. In terms of the wireless charging, particularly if you're looking at the larger machinery, you want to make sure that you're getting the optimum charging, obviously the performance output after as well. But just the sheer limit of capability for wireless charging. So that's an interesting observation to make. Just before we close, we spoke about obviously charging. We spoke about robots within industrial automation. But in the context of warehouse automation, what other areas within that are interesting from a TE connectivity perspective?
Yeah. So TE has been focusing, as I mentioned earlier, on different subsystems within warehouse automation, like AMRs, ASRS shuttles, electrical forklifts, and industrial robots or cobots. So I'll explain our broader interest with the help of the subsystem of industrial robots or cobots. Because industrial robots or cobots are a subsystem where you have a manipulator which runs with motors, and the manipulator is controlled by a controller which has drives and other accessories. And this kind of architecture is common for all other subsystems, whether it is AMRs, ASRs, shuttles, or automated e-forklifts. So when it comes to industrial robots, to explain it from the perspective of an industrial robot, so industrial robot consists of a manipulator, controller, and a teach-pendant unit. When it comes to the manipulators, TE has been a supplier of choice for industrial mini IO connectors, circular plastic connectors, heavy duty connectors, industrial RJ45 connectors, intercontact connectors, M8, M12 panel mounted connectors, safety torque sensors for cobots, dynamic D1000 slim connectors, which typically go inside the robot arm, and dynamic heavy duty connectors. As I mentioned, any kind of a manipulator, whether it is a mobile robot or an ASR shuttle, will have interest in all these components. But when it comes to the controller part, TE has been a major supplier of power resistors, terminal blocks, electromagnetic interference filters or EMI filters, board connectors, wire-to-board connectors, relays, terminals and splices, switches, and emergency buttons. So from the warehouse automation perspective, TE has an entire gamut of products and solutions which are well available in the market.
Fantastic. And I think it's important to call out as well, in terms of all of the infrastructure which is needed, and also as technology moves forward, connectivity is so important within all of those aspects, and it really is kind of like the starting point for consideration as far as I'm concerned. Connectivity is so important, for the operational effectiveness, but also the reliability and the robustness of the system. So I do thank you for your time today. Just before we close, we've covered a lot within this brief discussion. Challenges and solutions relating to the integration of AMRs and AGVs within existing systems. You commented on the opportunity in terms of how many percentage of warehouses are actually automated. There's still a lot to do, but also in terms of highlighting the scalability of T connectivity solutions with the growth and expansion and automation systems. There's still a lot of momentum to be made, particularly from T connectivity. Would you agree?
Yes, it is a very important point which you made. So, for example, if we look at the automation levels, which is still low, as I mentioned, basically how the automation is bound to happen is there is a warehouse with manual operation, and this goes for an automation. This typically requires the integration of AMRs into the warehouse, which is designed for manual operation. It roughly requires, let us say, addition of hardware and software in a broader term. So T connectivity's products and solutions are well evolved to be integrated into an existing manual warehouse, which is to be automated, as most of them are made into a plug and play kind of a products and solutions. Then on to the scalability part, which you mentioned. If we take blind mating charging connectors as an example, we have developed and industrialized the 40 ampere solution, and its evolution into higher charging current will be done considering minimum or no change in the warehousing infrastructure. So tomorrow, if the same warehouse requires higher payload AMRs, but with the navigation technology which allows for lower docking accuracy, we will have products which will be perfectly suited with minimum or no change in the warehouse infrastructure, which ensures scalability, in other words.
Yeah. That's a really good point to finish on, Guru. It's been such an interesting conversation, and I've really enjoyed just learning a little bit more about T's approach to this area within industrial automation landscape. So thanks for sharing your time today, and I hope we can have you on DesignSpark again sometime soon.